Hello, welcome to Scratch Course Episode 2. This episode will show you how to make a ball jointed arm. I'll be showing you how to make a basic ball jointed arm and how to reinforce your joints with multiple materials to lengthen their lifespan. Nothing here will need a dual extruding printer. Everything I make here should work on an out of the box Ender 3. Now the first step is to subscribe to the channel and like the video, because if you're following along with me, you'll want to know when the next episode comes out. The actual first step is to remake the round part of the shoulder wing. I didn't like what we made last time, so I'm going to show you what I did to fix it. I make a copy of the upper arm and delete the portion I would like to remake. I then make a new sketch on the flat part of the wing. The sketch is a 7mm circle with the line coming out of the center. The length of the line isn't important, it's more of an aesthetic choice. I then use the curved tool going from the tip of the line to the side of the circle to make a teardrop shape. Use the revolve tool to finish the shape. Then use the move tool to move it into place. The exact spot isn't really important, just do whatever feels right. Now join all the pieces of the wing together. Now for ease of printing and prototyping, we are going to remove the wing. There are a couple different ways to do this, but because we were working on a copy of the arm, I just deleted the face of the arm and left the wing. This sometimes can confuse Fusion 360, so if you run into issues, try to use a boolean or an extrude to remove the arm. Now we need to do the opposite for the original arm. Select all the wing faces and hit delete. You should be left with one upper arm and one shoulder wing. We will make a way to connect these later on, but when 3D printing and prototyping, you will want to remove parts that aren't functional and are just going to slow down the printing process. Now to start on the ball jointed arm. The first thing we'll need to do is remove the elbow section from the upper arm. For a ball jointed arm, we will be making a new elbow as we go. Make a sketch on the inside of the arm, and make a 10mm circle coming out of the middle of the upper edge, offset it by 2mm. Make another circle inside of the first, this time make it 8mm, and connect the edges of the circle to the top of the arm with 2 vertical lines. Finish the sketch, and on top of the arm make another sketch with another 10mm and 8mm circle. Connect the top and bottom of the inner circle to the edge of the arm with 2 horizontal lines. Your sketches should look something like this. Use the sphere tool to make a 10mm sphere and then center it on both of your sketches. Make a boolean with a cut operation. Use the shoulder as the body and the sphere as the tool, and have keep tools checked. This will cut a sphere shape out of the shoulder. You can't currently see it, but that's okay. Use the outliner and turn the sphere off. Now take the sketch you made on the inner arm and make a cut extrusion going into the shoulder. You should start to see the sphere cut now. Center the extrusion on the top of the circle you made. It should go exactly halfway into the sphere. Now make a second cut with your top sketch and do the same. Go straight down, center it on the sphere. You have now modeled the slot for the shoulder ball joint. Make another sphere and center it on the sketches from before. Then use the 8mm circle from before and extrude a cylinder into the sphere. Be sure you are only joining the new sphere and cylinder, and not joining anything to the arm. Make a sketch on the front plane. We are going to block out the shoulder joint for later. It'll also make the ball joint easier to print. Project the ball joint onto the sketch, and then coming out of the arm of the ball joint, make a 9mm circle and then square off the side facing the ball joint. Extrude the sketch so it's even on both sides of the cylinder. We'll use this as a base for when we work on the torso later. We're going to repeat a few of these steps for the elbow. When you make your sketch, remember to project all of the lower arm onto your sketch to make it easier to draw your lines. Instead of making the ball joint connect to a shoulder joint for later, extrude it to join with the upper arm. I moved the hand down to line up with the arm, but I wound up moving it down again further into the video. It might not matter with your sculpt, but I moved it down to make sure that the hand has enough room for rotation, just something to keep in mind. When you make the wrist, the sketches are going to be a bit different. The ball joints are going to be smaller, and that's going to change how things snap together. Make a sketch on the base of the wrist. Start with an 8mm and a 5mm circle centered on the middle of the wrist. Make a third circle halfway between the two. Do the same thing for the back of the arm. Extrude the middle circle on the lines extending downwards and cut into the center of the arm. Repeat this for the other sketch. Use the 8mm circle to make a sphere. Line up the sphere with the bottom sketch. Now use the sphere you made to cut a boolean in the arm. Make sure you have keep tools on. Use the original sketch for the wrist and extrude a 5mm cylinder into the ball. Make a sketch on the front of the hand and cut a 5mm circle going through. This will be used to hold most accessories. There will be another video on how to make a more detailed optional hand later. So now the arm looks finished, but unless your 3D printer is extremely tuned in, the arm won't work as is. We haven't put any tolerances in yet. You need to model tolerances into your model so everything can fit together. You always want to do tolerances last. Doing tolerances early in the design process can make things a bit confusing, especially when you're trying to make changes to other parts of the model. We're going to start with the push and pull tool. Go one by one, selecting the ball joints you have made, and use the push and pull tool, and then make -2 mm your offset. This is going to move those walls in by 0.2 mm. For a tight fit, use 0.2 mm. For a looser fit, use 0.3 mm. If you want something to spin freely, use 0.4 or 0.5. But when you go that loose, you'll need to make some additional modeling decisions to make sure everything stays pinned together. After you make all your offsets, go around and select the edges of all your ball joint sockets, and use the bevel tool to add a 1mm bevel to them all. The bevel allows a little bit more room for things to snap together, but doesn't actually affect the tightness of the joints. Now the arm is technically done, but I can tell you that if you make the arm like this, and use your figures regularly, the ball joints will wear out very quickly. Especially if you are printing in PLA. PLA has a bad habit of wearing itself down if you're up against more PLA. The easiest way to fight this in my experience is to use multiple materials. I use TPU and PLA. TPU is a semi-flexible filament, and against popular opinion, it prints quite easily. I'll share my TPU profile underneath this video. The trick is to use no retraction and to print slowly. So the easiest way to model this in is to make a copy of each of the bodies that have the ball joint peg. On the face where the ball joint is, make a sketch, and make a circle the same diameter as the ball joint peg. It should be 8mm for the shoulder and elbow, and 5mm for the wrist. On one of the copies, delete everything but the ball joint and peg. On the other, delete only the ball joint and peg, keeping the base of the object. Now extrude another cylinder and make it go halfway through the ball joint sphere. Only join the cylinder to the copy of the body without the ball joint. Make a sketch at the face of the cylinder and use it to make a half sphere. Now select the new pegs you have made and use the push and pull tool to add a -1mm offset. Use these new smaller pegs to make a cutout into the original ball joint. Make sure you have keep tools checked. Now one more time, add another -0.1mm offset to the new pegs. Now add a 0.1mm offset to the ball joints. You are using a 0.1mm offset here because TPU deforms under pressure, so it can get away with a lot tighter tolerances. You should be able to print the ball joints in TPU and the rest of the arm in whatever plastic you would like, and it should keep the tolerances rather tight for a long time. I'm going to do a quick show of how to snap everything together. Now yours might differ slightly depending on how you modeled everything at the blocking stage. So that should be all for now. Please like and subscribe to get the next episode of Scratch Course. And if you're following along with these videos, let me know how it was in the comments. If you have pictures of your arm, show me on Twitter at orc3dprint.